Hello YouTube folks, in this video tutorial I'm going to show you how you can create a chain in SOLIDWORKS so that it is engaged with other members of your assembly in a way that when you rotate one of the members, all the others rotate with it and change chain response to it accordingly. Before we start modeling everything, your assembly needs to have a couple of conditions into it. Let me suppress the features that I've used to generate the chain. So the assembly that I'm using, all these sprockets can be rotated with my mouse. That means they have to have at least 1 degree of freedom. If they're already fully defined via their mates, then when you apply that belt feature, this blue sketch, your assembly will be overly defined. So what this sketch does is that it kind of ties all these sprockets together and and engage them together as if there is actually a chain there. So and applies an extra mate on all these members, all these sprockets. When we did that, when we generated this sketch, then these sprockets will be engaged together. That is step one. In order to generate all the members of the chain, you need to have 2 seeds which SOLIDWORKS will use to create the whole chain on the pattern that you've already created. These seeds are the outer chain member and the inner one. You need to model them yourself or have a part document that to use as the outer and inner chain members. These outer and inner chain members have to have a couple of features into them. The most important one is a plane. Let me isolate them from the rest of the assembly. The most important one is a plane that you need to define inside that subassembly or that part. Then later SOLIDWORKS will use this plane and will mount the whole chain or this plane on that path that you have created before. To create this belt sketch, what you need to do, let me just delete it first so that I can show you how it works. To create the belt sketch, you need to go to Assembly tab, from there to Assembly Features, and then choose the belt or chain. Here you need to define or introduce the pitch diameter of the sprockets. It needs to be a circular edge, face, or cylindrical face. It doesn't need to be a complete circle necessarily, it just needs to be something with a curve. So when I click on this edge, this circular face, SOLIDWORKS takes the whole diameter as the pitch diameter of the sprocket. You can adjust the diameter, this value here if you want. If you know the exact pitch diameter, you can just enter it here, but you need to select a something in the graphic area. The next thing, so if this is my driving shaft and I know that this is going to be the first sprocket that is going to be rotated. If I select this one, you can see that this yellow line is going to be the belt or chain that SOLIDWORKS is going to generate for me. The next one that I'm going to select on is going to be this one. So one thing that I noticed is that this is not the order that I wanted to select my sprockets. I wanted this one to be the second one, this one the third one. So I can change the order here via these 2 buttons, move up and move down. I select the last one and move it upwards. And another thing that I want to do is changing the direction of the belt around the sprocket. And I'll show you why I need to do that. So I'm going to select the 4th one, As you can see, the belt has gone through this path, and I know that it is absolutely wrong. To fix it, I'm gonna just do that. You see this small arrow here, it flips the direction of the chain around the sprocket. You can either use the graphics area to flip the direction, or select that sprocket on the list, in this case the third one, and use this button here. So I'm going to go ahead with selecting my sprockets. Alright, so I'm going to stop here because I want to show you something. These last two ones, you see this, the belt has gone through the wrong path. If I flip the direction on this one, what I can see is that then, in order to satisfy with that condition, the belt needs to rotate around the whole sprocket. And I know that is absolutely not possible in my case, because it's not a belt, it is a chain. And also it's too close to this one, to the fifth one here, and I don't want to see that. So I realized that I need a dummy sprocket down here so that I can fix this issue that I have with these two last sprockets. Alright, so this seems to be the right path for my chain. What I want to do is for these rollers on the other side, you see these two arrows here, I want these rollers on this side to be rotated in a way that when I feed the sets of rollers with the sheet metal, they take it from this side and feed it to the next stage. So I want to make sure that the sprockets rotate in a direction to satisfy this condition. That is why I suggest that whenever there is more than 3 sprockets in your assembly, make sure that you use this belt or chain feature to make sure that you're running the belt through the right direction. So after I'm done with this, I need to select on this green check mark to accept all the conditions, but there is this feature here, engage belt. If I deselect it and clear that check mark, what happens is that when you rotate these sprockets, all the rest will not rotate with it, but when you select it, it will engage them together. This I have something here, use belt thickness. It is very useful when you want to use chains. What it does, it adds a thickness to the belt that you've defined. If say I'm gonna enter 10 here and select on the graphic area, then you can see that the length of the chain has changed to satisfy its thickness. This number here, which is grayed out and is not editable, is the total length of the chain. So that's it. I'm gonna select on the green check mark to accept everything. Later I'm gonna fix the belt thickness and adjust the belt length. So now that I've defined the chain, I expect these sprockets to be engaged together. Yeah, this is it works perfectly fine, and I don't see any error in my main assembly, and everything's fine. The next step is creating these two chain members here. You can define them and model them in a part document or in an assembly environment like the way I've done. The only important thing is that you need to make sure that obviously the internal dimension of the outer chain member matches the outer dimension of the inner chain member. But more important dimension that you need to take care of is the pitch of the chain member. This 19.08. Where did I get this number from? From the sprocket itself. So the sprockets and this black line here, 19.08, is going to be the number that you need to use for the distance between this face and this face. The sprockets that I've used, as you can see, are European type roller chains, which I've taken from SOLIDWORKS toolbox library. But obviously you can change your own, you can design your own sprockets and enter them into your assembly. but then you need to make sure that everything matches each other. So your sprockets and your chain members need to match together. Okay, the next thing that is very important is that the chain members need to have a plane inside them. You don't need to define this plane. You can use one of the primary planes if you want. But what SolidWorks does is that uses this plane and mounts the whole chain, the plane of the chain on that sketch pattern that I showed you earlier. Alright, now I have everything ready. I have my chain inner and outer members. I have my sprockets engaged together, and I have more importantly, I have my chain path. The next step is using chain component pattern from assembly tab under linear component pattern. This is the command that uses these inner and outer members and that chain path to generate the chain. There are three types of chain that I can, not types of chain, but mostly how the chain members will be connected together. The last one is the most common one, so I choose that one. The next thing to do is selecting the chain path, which is the sketch that the whole chain is going to be, all chain members going to be generated along. So I have this, I don't know if you can see my chain path, which was generated with the chain or belt feature earlier. But the thing is, when I select on one of its entities on this straight line, what SolidWorks does is that it takes that line only as the chain path. I want the whole path to be taken, whole sketch with all these curves to be taken as a chain path. So to make sure that that happens, I clear the selections here, then use selection manager. I use the select closed loop button, and then from the graphics area select on the sketch. As you can see, the whole path is taken, and then I right click or click on this green check mark to OK. Now as you can see, the name that is shown here is a closed loop that is situated in the labyrinth forming machine SLDASM. The next option that you need to take care of is the fill path option. When you select fill path, what it does is that it takes these two members and kind of generates them or makes a pattern of them along this path and takes care of all the numbers, all the quantities of the members that it requires. If you don't select it, you need to enter the numbers that you want your chain to have manually. It can be quite useful sometimes, but in most times you need to have SolidWorks to calculate the number of chain members. The next step is actually selecting the members for the chain and introducing them to this feature. You can select the first, it doesn't matter in which order you select them. You can order the outer member first or inner member first. So I select on this box here, and then from the graphics area I select my outer chain member. The next thing you need to define is to say which face will be mated to the next and previous chain member. So this one's going to be the face that is going to be mated to the next chain member, and this one's going to be the one that is going to be mated to the previous one. Then the path alignment plane is that plane that I mentioned earlier and I said is very important. For that, from the design tree in the graphics area, I go to the outer member, and I've already defined this member, this plane here. I just select this member, and what SolidWorks does is that it generates the whole chain as if the only member that it would have was the outer chain member. So it doesn't take into account the second member because I haven't introduced it yet. As you can see, another thing that I want to mention is that that plane in the chain member is mounted on the chain path. So on which plane your chain path is situated, this plane is going to be mounted on. You can use this to adjust the position of the chain on the sprockets. The next step is selecting the other chain member. When I do that, the chain disappears because then now I have to define the options of the second one. Like the one before, this is going to be the front hole, this is going to be the back one, and for the path alignment plane, I use the one that I defined in the inner chain member earlier, this one. Okay, so everything seems okay. And it is okay actually. One thing you need to do is to select either dynamic or static ones. I suggest using dynamic, and if you want to know more about these, you can use this button, the help button in SOLIDWORKS help document, and read about them. Doesn't actually cause that much difference. Dynamic is better as a rule of thumb. Okay, so I press on the OK, and my chain is generated for me. One thing that you need to notice here is that sometimes the last chain member is not shown because that is because the length of the chain, which is defined by the sketch, is not a total number of the quantity of the chain members. So this distance, what I'm trying to say by that is that this distance from this distance is 24.5, which is bigger than the chain pitch, which is 19.08. So SOLIDWORKS cannot generate another chain member to fill the gap. So what it does is that it just leaves it as is, and there are two ways to fix this issue. We can either adjust the length of the chain by changing the position of one of the members, or when you order the chain members, you just order a couple of extra spare chain members to rectify this problem. Regardless, most these mechanisms, such mechanisms with lots of sprockets in them, they usually have a chain adjustment mechanism, which I haven't shown in this assembly due to patent issues. But what they do is that they can adjust the tension of the chain. Currently it is quite tight. Obviously it's not going to be manufactured this way, but having a good representation of the chain in your assembly helps you to figure out hidden issues and avoiding surprises later down the track. Alright, so I've created my chain, and one thing that I noticed is that it doesn't respond to the movements of the sprockets, and that is because I need to apply a rack and pinion mate on the sprockets and the chains. To apply a rack and pinion mate on the sprocket and the chain, the thing about rack and pinion mate is that before you apply it, you need to make sure that the members are in the right position. By right position, I mean the desired position. There is no right here. So I want the sprocket to be in between these two members like that. This seems to be okay. The next step that you need to do is to applying the actual mate. You go to mechanical mates, and from there select on rack pinion. You need to define a straight line, edge, or not axis, maybe axis, yeah, for the rack, and the pinion pitch diameter. So the pinion is pretty straightforward. Is this line here, is this edge that we used for chain generation earlier, but the rack, I need to have a straight line or edge on the rack, which my model doesn't have. It's all curved and there is no straight line to be used for the mate. So what I've done, let me close here. What I've done is that in this chain, in this member, in this part model, I've defined a straight line for the sole purpose of using in that rack and pinion mate. If I go to mate property manager again and go to rack pinion, and for the rack or for the pinion, obviously I need to define this edge, this circular edge. For the rack, I'm going to select on that straight line, and that's it. These two are now connected to each other. The sprocket and the chain are connected to each other via a rack and pinion mate. The dimension here defines how the chain will be traveled around the rack and pinion. So you need to adjust this dimension to make sure that the sprocket is always, the sprocket teeth are always in between the chain members. Okay, so if I go to the sprocket, I can see that there is a rack and pinion mate applied on the sprocket and on the chain member as well. When I rotate the sprocket, everything's fine. There's no problem here. So that's it. You have all the model and all the features that I promised you in the beginning of the video, and I hope you enjoyed it. If you did, please press that like button and subscribe for future videos. Thank you so much for your time.